the pH is going to go up, 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 up slowly, and all of a sudden it's going to shoot straight up and then level out. And this is where you can just do a little stoichiometry calculation. So let me show you what I mean. And by titration, it's just really a neutralization reaction where we have an acid and a base. So for example, make sure you can write the neutralization reaction. I have a strong acid right here, hydrochloric. What's it going to do? Give up those H pluses. And then I have a strong base here. Look what he has. Hydroxides. What will we make? We will make water. And then what's left over? An aqueous salt. So let's look at a titration setup. We're going to put what we call the titrant, the titrant in the top of the burette, okay? And the titrant in this case, I'm going to use this next little example, is a strong base, the calcium hydroxide solution there, and then I'm going to put the acid in the bottom. This is hydrochloric acid solution, and this is what we call the analyte. And generally, I don't know the concentration of this, okay? So I've got a known concentration of my titrant, and I don't know the concentration of my analyte. I'm going to use some stoichiometry. I'm going to drop some little bit of volume at a time in there. And what's going to happen? Well, we start with a low pH because we have a strong acid, right? And this on the x-axis is the volume of base added. And so as I continue to add, the pH is going to go up, 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 up slowly, and all of a sudden it's going to shoot straight up and then level out. Okay, and that is what a titration curve looks like. And you will probably plot this, right? You've got a pH meter right here, and you'll look at that pH. You'll use a color indicator to let you know when you're getting really close to that steep part of the curve. Okay, this is an actual titration curve that I did with sodium hydroxide. And if you follow this smooth curve, see how it's barely increasing, and then all of a sudden it shoots straight up like this, and this point right here at 7 is what we call the equivalent point. And what is equivalent at this point? Well, if you drop down to this volume right here of sodium hydroxide that you added, the moles of base are equal to the moles of acid in that flask. Moles of base equal to moles of acid. And this is where you can just do a little stoichiometry calculation. So let me show you what I mean. So here is a titration. We've got calcium hydroxide. We've got calcium hydroxide in the flask, and we're going to drop in some hydrochloric acid. So let's do the stoichiometry of this. So first of all, I know the volume and the concentration of base. So let's start with that concentration, 0.25 moles per liter times 0.040 liters. All right, so that is my calcium hydroxide, right? And then I'm going to use a mole ratio here. I want to flip it over to hydrochloric acid. So check out my stoichiometry right here. So I've got 2 moles of hydrochloric acid for 1 mole of calcium hydroxide, because I am flipping over into hydrochloric acid. And then I know the concentration of my hydrochloric acid, so I want moles on the bottom. So 0.20 moles of hydrochloric per liter. All right, and when I do the math here, look what happens to my units. Moles of calcium hydroxide, liters cancel, and then I've got moles of hydrochloric. So I'm going to get liters of hydrochloric solution, and that would be 0.025 liters, and that would be 25 mils. So 25 mils of hydrochloric solution, okay, 0.20 molar solution, what would be necessary to titrate that amount of calcium hydroxide. Okay, so let me show you a super important part of the curve. Okay, so we talked about the equivalent point. We've got that labeled right here. That is the equivalent point. And then what I want you to look at right here, the base, the volume of the base that you need, you're going to pick off the graph. Okay, so when it is when you are at that equivalent point, that is the volume of base that you need. And what does that mean? That is the stoichiometric amount, the stoichiometric volume of base needed to do what? To react with the moles of acid that you have. Okay, and so what you're going to do is you're going to use that volume to calculate either the concentration of acid that you had or the volume of acid that you need. So I hope that helps. That's your first titration video. Make sure you watch the next one. You can do this.